Welcome back to Practical PyTorch. In this video we fix the gap from last time. The model memorized 50,000 fixed images, so its honest score stalled. The fix is simple. We show it a training set it cannot memorize. We change each training image a little every epoch, flips and crops. The model and the loop stay exactly the same. By the end, we measure whether the gap actually closed. Last video, the model memorized 50,000 fixed images. Its honest score stalled while training kept climbing. The fix is one idea. Show it a training set it can never memorize. The model and the loop do not change. Only the training images do, a little every epoch. This video has 3 parts. First, we watch augmentation act on one image, flip, crop, and jitter. Second, we build the transforms pipeline. We augment the training split only and normalize both splits. Third, we rerun last video's training and measure the gap. Did augmentation actually help? First, one image, and the many views augmentation can make from it. This is one training image, a horse. In the last video, this exact picture arrived every single epoch. Same pixels every time, so the model can just memorize them. Let's change that, one transform at a time. Flip the image left to right. The horse now faces the other way, but it is still a horse. This is random horizontal flip. The label stays the same, but the pixels are new. Now pad the image, then cut a random 32 by 32 window. The horse shifts a little in the frame. This is random crop with padding 4. The horse sits in a new spot each epoch. Nudge the brightness and color a little. The horse could be under a different light, still the same animal. This is color jitter, another common option. Our training run keeps it simple, though just crop and flip. Stack crop and flip together. The model now sees a fresh horse every epoch, shifted and mirrored at once. The label stays horse, while the pixels keep changing. Memorizing one picture no longer works, so the model must learn the pattern. Next, the transforms pipeline that puts these to work. Build 2 pipelines. The training one starts with random crop, which shifts the horse in the frame. Then random horizontal flip mirrors it. These 2 lines are the augmentation, and they run on training only. Then the image is normalized. Normalize uses the same mean and standard deviation as before. The validation pipeline normalizes with those same numbers. No augmentation is added to it. So augmentation goes on the training transform only. Normalization goes on both splits with the same numbers. A common slip is to reuse the training pipeline everywhere. Here, random crop has been added to the validation split. Random horizontal flip is on validation too. Now every validation pass sees different pixels. That makes the validation number noisy and different every epoch. You can no longer compare one epoch to the next. Augmentation is training only. Normalization is both. Now the real question, did any of this actually help? Same model, same recipe, only the training transform changed. This is validation accuracy per epoch for both runs. The red no augmentation curve rises fast, then settles near 71%. The blue with augmentation curve starts slower, then overtakes it. By epoch 20, it reaches 74.74%, and it is not overfitting. The table reads the same story. At epoch 1, both start low, training near 44, validation near 56. By epoch 8, Validation is already 71.5. That beats last video's final score. At epoch 14, it climbs to 73.6. By epoch 20, validation reaches 74.74, its best. Now compare the two runs. Without augmentation, validation stalled near 71% with a 17-point gap. With augmentation, it reaches almost 75, about 3.5 points higher. And training now sits below validation. The gap closed and even inverted to minus 2.14. The augmented images are harder and never repeat, so the model stops memorizing. Let's review. Random flips and crops multiply your data for free, same label, new pixels. Augmentation goes on the training split only. Normalization stays on both splits with the same numbers. The old gap is how we measured it worked. Validation rose to 74.74%. Next, we look beyond accuracy. Your turn. Suppose you add random crop to the validation transform too. What breaks? Pause and think it through. Okay, here it is. The comparison breaks. The validation number becomes noisy and different every epoch. You can no longer compare one epoch to the next. You have broken the one honest measurement you had. Validation accuracy went up, but a single number hides a lot. It cannot tell you which classes the model confuses. Next time we read the confusion matrix, which shows exactly that. See you there.